Hello and welcome. In this explainer, we're going to tackle a skill that's absolutely essential for any engineer or project manager, figuring out the weight of a steel plate. Let's get right into it. So here's a thought. How do you weigh a massive 10-ton steel beam before it even exists? Sounds like a riddle, doesn't it? But it's not. In the world of engineering and fabrication, you absolutely have to know the weight of things long before they're physically there. And the answer? It all comes down to a simple, super reliable calculation. So, why do we even care about this? I mean, why is it so important? This isn't just some boring textbook problem. Getting the weight right has huge real-world consequences. We're talking about everything from the project's budget to everyone's safety on site. And you can see just how much it matters right here. Think about it. For material procurement, you need the weight to order the right amount of steel and not waste money. For structural design, engineers have to know the weight to make sure a building or a bridge is actually safe and won't collapse. Then there's logistics. You got to know if the truck can even carry the thing. And for crane operations, lifting something that's heavier than the crane's limit is just asking for a disaster. Every single one of these points rolls up into project estimation. A good weight calculation can literally be the difference between winning a job and losing a ton of money. Okay, let's switch gears and look at the basic science behind all of this. It's actually wonderfully simple, and it's the foundation for everything we're about to do. And here it is. This is the one formula you absolutely have to remember. Weight equals volume times density. Seriously, every single calculation we're going to look at today starts right here, with this one basic law of physics. So let's break down those two parts, volume and density. First up, we have volume. It's just the amount of 3D space something takes up. For a simple flat plate like we're talking about, you just find it by multiplying its length, by its width, and then by its thickness. Pretty easy, right? And the second piece of the puzzle is density. All this means is how much stuff is packed into a certain space. Different materials have different densities. But here's the key. For the mild steel we use all the time, the entire industry uses one standard, agreed upon value, and that makes our lives so much easier. And here is that magic number. The standard density for mild steel is 7,850 kilograms per cubic meter. This number is used in engineering formulas all over the world. So if there's one number to remember from today, it's this one. Okay, now that we've got the physics down, let's jump into our first practical method. This is the standard way of doing things using SI units, meters. It's really common in design and engineering offices. The whole process is just a simple three-step recipe. First, you make sure all your dimensions, length, width, and thickness, are in meters, no exceptions. Second, you calculate the volume in cubic meters. And third, you multiply that volume by our trusty density, 7,850. All right, let's walk through an example together. Let's say we have a steel plate that's 2 meters long, 1 meter wide, and 10 millimeters thick. Let's find out how much it weighs. So, following our steps, what's the very first thing we do? We have to get all our units to match. The length and width are already in meters, that's great, but the thickness is in millimeters. So we'll convert 10 millimeters into meters, which is 0.010 meters. And now for the last part. We calculate the volume. That's 2 times 1 times 0.010, which gives us 0.020 cubic meters. Then we take that volume and multiply it by our steel density, 0.020 times 7,850, and that gives us a final weight of 157 kilograms. See? It's all very logical. Now, let's look at another way to get this done. This second method is a really handy shortcut. A lot of people call it the shop floor formula because it's perfect for how people work out in the fabrication workshop. This formula is a fantastic time saver because on the workshop floor, almost everything is measured in millimeters. What's so great about this formula is that it has the unit conversion built right into it. That means you can just plug in your millimeter measurements directly without doing any extra conversion steps. Okay, just to prove that both methods are rock solid, let's try a new plate. This one's a little different, 2.5 meters long, 1.2 meters wide, and 15 millimeters thick. We're going to solve it using the meter method and the millimeter method, and we'll see if we get the exact same answer. And look at that. The results are in. On the left, using our metry method, we get 353.25 kilograms. And on the right, when we plug the millimeter dimensions straight into that shop floor formula, we get the exact same weight, 353.25 kilograms. This proves it. Both methods work perfectly. So, knowing the formulas is one thing, but knowing how to avoid common mistakes, well, that's what makes you a true professional. Let's go over a few potential traps and the best ways to make sure your calculations are spot on every time. This is a big one. That number we memorized, 7,850, is specifically for mild steel. If you're working with something else, you have to use its correct density. Take aluminum, for example. It's almost 3 times lighter than steel. If you use the steel density for an aluminum plate, your answer would be completely wrong. So always check what material you're working with. Here are 4 classic mistakes you want to steer clear of. First, mixing your units, like using meters for length and millimeters for thickness in the same formula. That'll get you a wrong answer for sure. Second, like we just said, using the wrong density for your material. Third is something called rolling tolerances. That just means a steel plate isn't perfectly even. Its thickness can vary a tiny bit, which can matter for really critical jobs. And finally, don't round your numbers until you're at the very end. Keep it precise. And here's how to do it right every single time. First, always standardize your units before you even start calculating. Just take an extra second to double check your decimal points, especially going from millimeters to meters. If you do this a lot, make yourself a simple spreadsheet template. It'll save you from silly mistakes. And last but not least, always write down which density you used so anyone else can easily check your work. So let's bring it all home. What did we learn today? The entire process is built on that one simple foundation: weight equals volume times density. We've shown that both the meter and the millimeter methods give you the same consistent result. And really, the best thing you can do is to put a standard process in place, like a template, to guarantee accuracy every time. If you found this content helpful, please subscribe to my channel for more engineering and technical tutorials. And hey, one more thing. If you want a ready-made steel weight calculation sheet, just write your email ID in the comments and I will share it with you.